At this point, students have selected their game graphics and written linear functions that cause their danger and target to move across the screen. However, once a character goes off the edge of the screen, it disappears. We want them to come back, and that's exactly what this unit does. This lesson introduces inequalities in the plane, using boundary detection in student games to motivate the need for Booleans and inequalities in the plane. By now, students should be comfortable with the circles of evaluation and the design recipe. The recipe is introduced in Unit 3, then reinforced in Unit 4 with some sample exercises, and in Unit 5 with character animation. The unit begins by asking students to convert a series of simple expressions into code and then evaluate them. 4 times 2, 5 minus 1, etc. Finally, students are shown a new expression, greater than 4, 2. What will this expression evaluate to? This expression evaluates to true. But what is true? Is that a number, a string, or an image? The value true is a new data type called a Boolean. Ask students what they expect to get if the numbers were reversed, 2 greater than 4. Not only do we have a new data type, but we've also introduced a new function called greater than. Have students write the contract for this function. Can they guess the contracts for other functions? Have students write down these contracts and then give them some time to practice using them on the computer. Make sure to remind them that the inputs can be more complex than 2 numbers. They can be sub-expressions themselves, as long as they both evaluate to a number. Once students are comfortable with Booleans, the lesson introduces Sam the butterfly. This activity asks students to help keep a butterfly inside his mom's yard, which just happens to have the same dimensions as their video game screen. Students can move Sam around with the arrow keys, and they quickly realize that Sam is able to leave the yard. Their job is to modify the program so that he stays put. This activity begins with an exploration, where students discover the boundary conditions for the left and right sides of the screen. This also gives them a refresher on coordinates, which play a large role in the activity. Note that there's a roughly 50 pixel barrier on each side of the screen, since Sam can go about 50 pixels beyond the edge before he totally disappears. Students can then use the design recipe to write functions that produce true or false, depending on Sam's location on the screen. Each of these functions checks Sam's positions against the left and right edge of the screen, testing his position on only one side at a time. The lesson then introduces and or, which allows students to combine these tests into a single expression. Because Sam is sometimes on the screen and sometimes off the screen, some of the examples will return true, while others should return false. Watch out for students who confuse false with wrong. You'll want to explicitly point out that Sam is off the screen when his x-coordinate is 1000, and that whatever example they write for this should return false. Once students have protected Sam on both sides of the screen, the exact same code can be dropped into their video games.